All right, welcome back to part 2 of Notes 8.23. Let's do some proofs. Yay, proofs! Okay, so we need to prove that angle B is congruent to angle D. That's our goal. And we know that side BC is congruent to side AD, so let's write this down. 1, we know that BC is congruent to AD, and we also know from the diagram that BC is parallel to AD. Because it's marked in the diagram, that means that it is a given. Well, if that's true, then what does that mean? Well, if I have one pair of sides that are both parallel and congruent, then I have a parallelogram. So ABCD is a parallelogram. And my reason for that is if one pair of sides is both parallel and congruent, then I have a parallelogram. All right, so that's how I'm going to abbreviate it. So if one pair of sides is both parallel and congruent, then a parallelogram, which means that, I'm going to leave some space here since I took up so much room, I can now say that angle B is congruent to angle D. And what is my reason for that? If it's a parallelogram, which we have just proven, then I'm going to write both pairs, even though we're only talking about one pair. Then both pairs, opposite angles, congruent. And that's our reason. And we have in 3 steps proven that angle B is congruent to angle D. Pretty straightforward, not so bad, right? All right, so here we're given quadrilateral GHJK, and we're told some stuff about the various angles, and it asks you to find the measure of angle K. I'm going to ask you to do that in your notes check, okay, because it's really not hard. Let's talk about the proof part of it, though. We need to prove that GH is parallel to JK, so it might be helpful if we drew a picture of what we're talking about. See if I can find a parallelogram up here. No, I can't. All right, I'm just going to have to draw a parallelogram, unfortunately. Hang on, maybe there's one. There's one. Okay, so parallelogram, and we got to label it. G, H, J, K. Remember, we always run around either clockwise or counterclockwise. Okay, so I have to prove that GH is parallel to JK. And these are the things that I know. I know that the measure of angle G is 55 degrees, and I know that J is 55 degrees, and I know that H is 125 degrees. And those are my givens, okay? That doesn't include this, which we found, but we're not going to use that in our proof. So, what would be a good method of proving that these two sides are parallel? Well, it would be to prove that these two angles are supplementary, which they are. So let's start by talking about those two angles. The measure of angle H equals 125 degrees, and the measure of angle J equals 55 degrees. And that is given. Okay, if this is true, then since 125 plus 55 is 180, that means they are supplementary. So angle H is supplementary to angle J. What is the reason for that? Well, that would be the definition of supplementary angles, which is that their sums are 180 degrees. Okay, now, how does that help us? Well, if these two angles are supplementary and they are consecutive interior angles, then my lines must be parallel. So we can go ahead and we can state that GH is parallel to JK. And our reason for that is if consecutive angles sup, remember our old friend, then lines parallel. All right, so this one really didn't even necessarily have a whole lot to do with the fact that this was a parallelogram. In fact, we were never told it was a parallelogram. We were only given that it was a quadrilateral. Now, we know now that it's a parallelogram, but that is beside the point. All right, moving on. Okay, I would like you to attempt this proof by yourself. You're given this information, so basically you are given this, my little hint, and you need to prove that this side is congruent to this side. So I would like you to go ahead and attempt this proof, and then come back and check your answers when you're done. So hit pause now. Okay, I've given you now the left-hand side. Check your left-hand side. If you got it exactly the same, then you probably have the right-hand side the same. If you got a little lost, a little confused, didn't quite understand what was going on, now I've given you the left-hand side, and I would like you to fill in the right-hand side. Note that I needed to add an extra point here to kind of make this a little easier to describe what was going on in this picture. So, if you got the left-hand side correct, keep listening. If you got the left-hand side wrong, then write down this left-hand side and fill in the right-hand side and hit pause now. Okay, so either you're still here or you're back, in which case we now have the right-hand side. So let's talk about this whole proof. We're given that these guys are congruent to each other. And that means that the diagonal BD and diagonal AC bisect each other. That is the definition of a segment bisector, is that they cut each other into two congruent pieces. Okay, if the diagonals bisect each other, then we have a parallelogram going on. So ABCD is a parallelogram because if both diagonals bisect each other, then parallelogram. Finally, that means that side AB is congruent to side CD because if it's a parallelogram, then both pairs of opposite sides are congruent. Any questions? Ask in class. All right, I would like you to find the value of x that makes PQRS a parallelogram, and I would like you to give it to me in the notes check. I would also like you to answer this one for the notes check, please. The value of x that makes this quadrilateral a parallelogram. Okay, let's talk about coordinate proofs that something is a parallelogram. So we've got this parallelogram on a coordinate plane, and we need to figure out the ways we can show it's a parallelogram. So the easiest way, I think, is, let me see, if both pairs, opposite sides, parallel, then parallelogram. All right, so what do I need to show that both pairs of opposite sides are parallel? Well, I need to find the slopes. So find slopes of all four sides. And they should be, if parallel, then they'll have the same slope. All right, so that would be my first method of proving that this is a parallelogram. All right, what would a good second method be? Well, if both pairs of opposite sides were congruent. And how would I do that? We would need to use distance formula. To find the length of all four sides. All right, then parallelogram. Okay, the reason why I'm writing this is because, I'm actually going to ask you to do this. I'm going to ask you to do it in a quiz. I'm going to ask you to do it in the test. I'm going to ask you to do it in the final exam. And when you do it, you need to, for example, if you do this, you say, okay, I'm going to do it by proving both pairs of opposite sides are parallel. So you find the slopes of each, and you tell me that the slope of this is, 1, and the slope of this is 1, and the slope of this is -2, and the slope of that is -2. Bam, done. Well, you're not done. In addition to finding the slopes, you need to make this statement. If both pairs of opposite sides are parallel, then I have a parallelogram. Okay, so when I ask you to do a coordinate proof, which is what this is, coordinate proof, you need to not only do the proof with the coordinates, but then tell me what the reason is, what the justification for the method you did the proof with. All right, let's see. Are there any other ways to prove that this is a parallelogram? Well, we found slope and we found distance. What if we just did that for one pair of sides? So if one pair of opposite sides is parallel and congruent, then parallelogram. Okay, and in order to do that, we would need to find slope and distance of one pair of opposite sides. All right, and there's one final method we can do on the coordinate plane, and that would be if diagonals bisect each other, then it's a parallelogram. How would we show that on a coordinate plane? Well, we would find the midpoint of both diagonals. Diagonals, I don't think I spelled that right, diagonals, and it should be the same. If that's true, then we know that the diagonals bisect each other and we have a parallelogram. So what method could we not use in a coordinate plane? This is the one where if both pairs of opposite angles were congruent. Okay, that would be very difficult to prove with a coordinate plane. Could be done using trig, but I would really rather not. So, these four methods are useful in a coordinate proof. This one is not. When you use the methods, make sure that not only do you find all the pieces, but that you make the statement. Clear? All right, we have two more proofs left in these notes. Here's what I want to happen. I want you to attempt both of these proofs, and then we are going to go over them in class because there's some interesting things that happen in these, and we're going to do a whole bunch of proofs this unit. So you should get good at them. So do this one and this next one. This one's not so bad, and we'll talk about it in class tomorrow. And that concludes these notes. Please make sure you go on and do the notes check. Thanks.